Okay, let me know when you can see my screen.
Yeah, I can see it.
Great. So today we are going to be talking more about strings in these subtopics, which I picked from the book. And like we know in Python, strings are in quotation. So maybe I can say st equals to string like this. So we have it in parentheses. Now there are certain operations that we can do on a string, which we'll talk about some of them today. The first, I believe we've touched some of them, some of these operations in some previous lectures. So one of them is concatenation. So one thing with strings is you can concatenate them using the plus. So if I have string 1 equal to my name is, and then string 2 equal to John, my name is John. So these are two strings. Now, if I want to concatenate them, which means like add them together, I can say string 3 should be equal to string 1 plus string 2. So concatenation is like joining. So let me print it so we'll see. String 3. Save it. So you can see the result. My name is John. So basically it is adding the two, joining them together. So when we concatenate them, we join them together using the plus, just like addition. You know, if you're dealing with numbers, when you use addition, the normal way we know it, the numbers is sum together. But in this way, when it's strings and you call the plus on them, it would join them together. And then when we want to repeat a string a number of times, we can use the multiplication. So I can say string 4 should be equal to string 2 times, let's say 10. So string 2 is John. So if I multiply by 10 and print it out, we'll see how it will look. I save it. No, let me comment this one. And then we run it in the terminal. So you can see John times 10. So when you want to perform repetitions in a string, you use multiplication. And when you want to join two strings together, you can use plus. You can do it for multiple strings, not just two, as many as you want. Okay. Another thing we need to, which I believe we should know by now, is most times we will say something like num equal to eval input. Then we can say like this thing jumping. What is your name? You can ask somebody a question like this using the input. Or what is your age? Let me put it that way now. Now, what I want to bring out from this is the input itself always brings in values as string. But from time to time, we use eval to evaluate these values to be seen as number. Okay. But normally, if you don't have eval, what this will result into is a string whenever it comes into your code. It will come in as a string. Okay. Now, there is something about string that we also need to know, which is it's an iterable. You can iterate over it. And when we talk about iterable, what is an iterable? It's something that you can go through one after the other. Like when you have maybe a list of elements, you can say the first one, the second one, the third one, the fourth one, you can go through it. So there's something about list. It's also an iterable. So if you look at this John, let me just bring this string down. So if you look at the string John, what I mean by iterable is you can move through like John, like let me do it this way. You know, in Python, we start counting from, or in programming, we usually count from 0. So we can have 0. J is on 0 position, for instance. And then O is on 1. H is on 2. And then the N is on 3. So what I'm trying to say is that this J is corresponding to 0, O is corresponding to 1, 2. So this way now you can go through a string one by one, 0, 1, 2, 3, and pick out the individual elements. So that's why we call it an iterable. Anything that you can iterate over, you can go through, it's an iterable. Strings are iterable, and hence they have index. And that's what we mean by the index for J is 0. The index for O is 1. The index for H is 2. The index for N is 3. I don't know if that's clear or anybody has any confusion with that.
Yes, it's clear.
Okay, thank you. So it's like a container. Strings are like that. So if you pick this string that I put here, this other string, what is your age? You can see that you have W on 0, H on 1, A on 2, T on 3. Now, this space before I is also part of the string. So this space is on 4. Okay. So the string now is everything within the parentheses, not just the letters or numbers or symbols. The space also is counted in the string. Is occupying something there. So it also has an index. So because it's an iterable, we can also use the in operator. First of all, we can index into it. What do we mean by indexing? Let me clean this. And remember that we call this one string 2. So let's put it like this. I can then say print string 2 with a square bracket. I can say 0. Okay. Those numbers we are talking about, I can print the element on 1. I can print the element on 2. So let's just save it as this and then run the file. First of all, I don't want to see string 4, so I make it a comment. Save it again. I only want to see these 3 prints. No, I don't want to see what is your age. Let me just give it. How old are you? So let me just put something. But you see the key thing, let me back this one up. let's forget about this input now. I just wanted to mention that. You see, when I say print string 2 index 0, it came out J, index 1, O, and H. So you can index into a string and pick out elements at different positions in the string. Once you understand how it is numbered from 0 to any number of characters it contains, you can just print any of them. And in this indexing, we can also perform slicing operations. This slicing operation is where we pick out a range. For instance, I can also say print similar to what we have in the range. You know, in range we have start, stop, right? In list, you could also do something like that. For instance, that John st2, which is string 2, we can have it. Somebody can say, give me from 1, start at 1, and end in 3. So remember, it has 0, 1, 2, 3. So it will print O and H, excluding the element on index 5. Just the same way in range, the end is also not included. Similarly, we can slice a string this way. And if I change this one to comment so we can see the result. No, my print should be curly bracket, not square bracket. So that gave an error. Save it again and run it. So you can see, let me clear my screen so it's clear. Running. So you can see it's printed the elements at index 1 and index 2. It did not print the element at index 3 because it's not included. It's just similar to range. When you're working with the range function, we'll say for I in range, you have start, just like this. So you can specify a starting index. You can also specify an ending index. And also you can specify the step, just the same parameters that we put in the same parameters we put in range, start, end, and step. When you don't specify the step is also 1. So you can jump a certain number of elements, slicing a list. Do we understand?
Yes.
Great. Also, we can also pick out some key elements of a list, like to get the last element, you can use -1. It prints the last element in the list. If you want to get the second to the last element, you make it 2, -2, and so on and so forth. So it counts -1, -2 will be H. And also you can maybe start at -2 and to the end, slice it, right? So why we can do all this is because it has index and it's an iterable. Okay, you can iterate over it. You can go through it from one to the other. So that brings us to the in operator. We can also then, just the same way you say for I in range, right? For I in range, you can also have that in operators on string. You can have something like this. If O in str. Print yes. Or you can print anything you want. So it's just like an if statement, checking if the string O is found in str2, which is st2, sorry, not str2, st2, which is John. We defined it to be John, right? So you can check if O is in this. And this will evaluate, like we talk about the if statement, the expression always evaluates to true or false. So this will evaluate either to be true or to be false, depending on if this string O is in st2. And if it is true, then we will print yes. Okay. So you can have things like this. To check if something is contained in a string, we use the in operator. This in the string. Okay. And the same vein, we can say something like, we can use not if, let's say, I not in st2. Remember what I said about the not operator before? Not kind of changes the final result. So for instance, if this was to evaluate to true, when you add not, it changes that true to false. So if I is not in this, you can have another expression. Print I not in string. Okay. So we have the not operator, which we can also use to check if something is not. You want to check if this is not in the string. And also you want to check if this is in the string. So you use the in, and then the other one you use the not. Like there's an example that is given in the book, which is very good. And someone is trying to check if a string is maybe a vowel. You know how we have vowels as A, E, I, O, U. Let me say like this. Vowels. Because say as a string A, E, I, O, U. Okay. And then you're asked to check if a letter is a vowel. So you could find somebody write something like this. If, let's say the letter, you're given a letter is equal to Z, and then they ask you to check if it is a vowel. So you could write it like this: if letter equal to A, or letter equal to E, or letter equal to I, or letter equal to O, or letter equal to U. It's long, right? Let me just try and reduce it by calling it L instead of letter. So we can see it. So a variable L is Z, and we want you to check if it's a vowel. This is vowel. You could write it like this: if L is A, or L is E, or L is that, then you say it's a vowel, right? And then if it's one of them, you can print. it is a vowel. But because of the in operator, you can simplify this whole expression instead of checking it one by one to something like this. If L in A, E, I, O, U. Because remember, we said it's an iterable. You can iterate over it. Because it's an iterable, if you have this like this, you can check. It's the same as this long thing. So if you didn't have the in operator, maybe you write it like this and check it one by one. But because of the in operator, you can just write this and simply check it directly. Are we okay?
Yes, yes.
Yes, it's okay.
Okay, great. So using all this, we can then move to the next one. Okay, we've actually talked about slicing now. We talked about it earlier. Then changing individual characters of a string. Now, for you to change a character in a string, you can then apply this slicing and concatenation to change the characters in the string. Let me write this note B. Note behind strings are immutable. Does anybody know what this means? Hmm?
No.
Please, let's take note of these keywords. When we say a string is an iterable, it's a keyword, right? All these things we are discussing like this, you need to know about it. You can index it. It's an iterable. And now I'm saying it's immutable. It's also a keyword. Now, when we say something is immutable, it simply means it cannot be changed once created. So it's once you have created a string, you cannot change it. But there are ways to go around it, is where we now begin to manipulate strings using all this that we know about strings. So what I'm trying to say is, as we defined this string here, st2 equal to John, once it's created in the computer memory, like this, you cannot come and change H directly. Maybe change it to J, because it's immutable, you can't change. When we say something is immutable, you can't change it. Now, to change it now, we can then begin to maybe slice it and add something else. For instance, now, if we wanted to change H, you wanted to change H now to P, we can slice it. Let me say new st2 will now be equal to st2, which is the string itself. We can slice it starting from 0 to, who can tell me where? Who can tell me where we'll slice it to? We are starting from 0. We are trying to replace. Hello?
Yeah, I'm with you.
Hello.
I thought I heard somebody saying something. Okay. We are trying to replace H now. So I just said we can start from 0, of course, because we want to slice it. The idea is to slice it to O and then put something else, then take the end. So basically we'll slice J
Two.
to O, 0, 1, 2. Great. So somebody has gotten it. We slice it to 2. That will give us J, O. And then we can use concatenation and add P since we want to include P. Then add again the last part, which will be, you can say -1, right? Because it's just the last. So this will create another string, a new string, okay, to replace this one. But it doesn't modify this one. You're just like creating another string with P in there. Now we could actually still name it ST2. Okay. So if I do it like this, it will look as though I've changed the variable, but I didn't actually change it. I only created a new variable and then used the same name to reference it. That's like called it the same name. But in memory, it doesn't change the original string. It just changes the reference, because whenever you assign a value to a variable like this, the value exists in a certain location in our computer, and then the variable is a pointer to that location. So now we are pointing to another location where the new string is created, because we cannot modify the string. Does that make sense?
Yes, it does. Yeah.
So, what if we want to reference? How do we now reference to the particular one?
Like as I put it now, I'm referencing the new one. All of this is a new string, right?
Okay,
But
let's assume we want to print and we say ST2. How do we know the particular one that we're referencing to?
okay, great question. Now remember, Python works serially, line by line. Okay. So the moment you get to this line 54, after 54, if you say print, ST2 has a new meaning. Okay. The first meaning at 52 is John, but at this point now, we mean this JOPN, because we changed the H to P. But what I'm trying to explain to you is to let you understand that this operation is not actually modifying the original string, but creating a new one and assigning it to this same name, right? So if you come and print ST2, it will now show the new value. It will not show the old value, okay? Now, somebody may say, okay, where is the old value? In the computer memory, the old value no longer has any pointer. Nothing is pointing to it, so it's kind of lost in space, okay? It's lost in space. So later on, we'll talk about memory management, but that will be later. Then you understand what happens to it whenever it loses its reference, okay? But at this point, at line 54, nobody's referencing John again. John is somewhere in your computer. It's somewhere. It's a memory location occupied by that string. But when you do when we change the string name to point to another string, that first string loses reference. So there's nothing else in this our code pointing to it. So it's just like hanging there. Yeah. So, but in the computer, there is another way we now manage that memory space, which Python has a certain implementation that manages that, right? That we call it the garbage collector. Anyway, but later you understand it more. Let's not delve into that side. So, but I'm just trying to stress that it is immutable. This is something you have to know, because there are other data types in Python that are mutable. So strings are immutable. You cannot change them once they are created. But this is one way you can update it. Okay. Any other question? Okay, we move on.
Yeah.
Go ahead. Who is speaking?
It's clear, it's clear.
Okay. Because there's another data structure we'll get to, and then this indexing, this thing we did here, we will use it to change like this stuff now. When we index into the string, we can use it, for instance, if we're dealing with list, we can use this index in list too and change elements in list, but you can't do it in string. But just understand that it's immutable. It's a property of string. You need to know and then go forward from there. Later, when we get to list, you will see that list, you can mutate it, you can change it, but you can't change this one. If you try it, it won't work, because normally if it was mutable, you could say something like this: st2, this thing we wanted to change, h is sitting on position 2. You could have done